this is what it would have looked like. If you pick, let's say, this point and that point, because that's where they cross exactly. You're looking for a point where it crosses exactly. You can see that that crosses and this crosses. And then you can just walk. You went up 1, so that's your numerator. And then you went right 6, so that's your denominator. This one you went up 1 and right 5, so that had a slope of 1/5. This went up 1 and right 6, so that has a slope of 1/6. So from this, you can say that A is parallel to C. A is parallel to C. Line A, down 3 and right 4. So you would go down 3, right 4. For line B, you go up 3 and right 4. All right. And so for this one, you have a positive and negative slope. And while they look like they might be perpendicular, what do you notice about them? They just have, they're negatives, but they're not reciprocals of each other, right? They're not reciprocals of each other. And so since they're not reciprocals of each other, they are neither. They are not perpendicular. And so you're just going to say that they would be neither. So if it was asking, is it parallel, perpendicular, or neither, this one would be neither. It's neither parallel or perpendicular. So this section is all about equations of lines. We actually did this a little bit in Algebra 1. We're going to do a little bit more with it this year. So the standard form of an equation. So the first equation they introduce is the standard form of equation. This is specifically a linear equation on the Cartesian plane. And it is in the form ax plus by equals c. So your x's and y's will be on the same side of the equation, and your constant will be on the other side. Specifically, a and b are not 0. The constants a, b, and c are expressed as integers, which means you want to take out all your fractions, and a is positive. All right, so these are just kind of the standard rules for standard form. So the format here is ax plus by equals c. A, b, and c are integers, so you will not have fractions. If you have fractions, you need to multiply by the common denominator all the way across and get rid of your fractions. A is always positive. If a ends up being negative, then you need to divide everything by -1 and change it where a is positive, okay? When you have a form like this, standard form, to graph a line, you just need 2 points, okay? Any 2 points on the line and you can graph it. 2 points, you connect the line, connect the points, you have the line. And so when it's in this form, it's easiest to graph a line using the x and y intercepts. Because to find them, you just make the other one 0. So if I want to find the y-intercept, I make the group with the ax 0 and then just divide by the number in front of y, and vice versa for the x-intercept. And so we're going to do that right now in example 1. They've given us the standard form of this equation, 2x minus 3y equals -6. 2, -3, and -6 are all integers, so we don't have fractions. 2 is a positive number. This is the standard form of this line. They want us to find the x and y intercept, and then they want us to graph this line. So the first question says locate the y-intercept. So if I take this equation and I want to find my y-intercept, in order to find y-intercept, then you make your x equal to 0. That's how you find it. So I'm going to do just that. I'm going to say, well, if x is 0, then it's going to look like this, which means the ax part of it just zeroes out. Okay, it's just gone because it's a 0. And I'm left with just -3y equals -6. So what is my y here? Divide both sides by -3. Y equals 2. So my y-intercept is going to be 0, 2. 0, 2, which means I plot that point. Y-intercept on the y-axis, 0, 2. That is my y-intercept. For my x-intercept, I do the same thing, but I do it with my y value. So I'm going to say 2x minus 3 times 0. So in this case, I make my y equal to 0. which means the y part of it cancels out. And I'm left with just 2x equals negative 6. So x equals negative 3. So my x-intercept is negative 3, 0. And I put that on my graph. Left 3, and I don't move up or down. It's on the x-axis, hence the x-intercept. Once I have any 2 points of my line, I can graph my line. I just connect the dots. So I just take those 2 points and I connect them. You want to go past them, go through them, and you want arrows at either end. A line is infinite, and so you are indicating with those arrows that this is an infinite line, as they all are. So find your x and y intercept, put them on your Cartesian plane, and then draw a line through it. All right, so I want you to try some of these. All right, so your x-intercept here. X-intercept, you make your y 0, so you end up with just x equals 6. So your x-intercept here is 6, 0. Which I did not. There we go. For your y-intercept, you make your x 0, so you're going to have negative 2y equals 6. So y equals negative 3. So negative 3, 0, wrong way, 0, negative 3. 0, negative 3 is going to be your y-intercept. And then you're just going to connect those two. So check your graph and check your intercepts. The next form, rather, of a linear equation that we have is the most common one that you will see. It is called the slope-intercept form of the equation. The slope-intercept form is in the form y equals mx plus b. All right? In this form, you can have fractions, that's fine. Your y has to be completely by itself. There cannot be a number in front of your y, or you do not have it in slope-intercept form. All right? If your y is completely solved for itself, if you have y completely on one side by itself, then you have it in slope-intercept form. The m, or the number in front of the x in this form, is your slope. The b, or the constant, is going to be your y-intercept. So when you have it in this form, the easiest way to graph is to graph your y-intercept. That's just where it's going to fall on your y-axis, and then walk from there using your slope. Okay? So what they want us to do here is they want us to write this in slope-intercept form, and then they want us to graph it. All right? So our goal here then is to get y completely by itself. We start out with the equation 3x plus 4y equals negative 4. In order to get y by itself, I have to move that x over. You move it with addition or subtraction. In this case, subtraction. You move the x over using addition or subtraction. So then I will have 4y equals negative 3x minus 4. Negative 3x minus 4. My y is still not by itself, so I need to go and divide every single thing by 4. Every piece of it is going to be divided by that 4. And so now I will have the y by itself. I will have negative 3/4. You want to put it as a coefficient. Negative 3/4 x minus, and 4 divided by 4 is 1. All right? So I have y equals negative 3/4 x minus 1. To graph this, I want to always start with my y-intercept. My y-intercept is negative 1, so I go to my y-axis. Don't get this backwards, because a lot of people go on the x-axis and then your line's incorrect. This is the y-intercept, y-axis. And I'm going to plot that point, which is negative 1. From there, I am going to walk using my slope. My slope is negative 3/4. This means that either I have a negative 3 over a positive 4 or a positive 3 over a negative 4. I'm telling you that because sometimes your slope will take you off the graph and you won't be able to graph correctly. So then go the opposite way. All right? You can go both ways, but you only need to go one. So negative 3/4. If my numerator is negative, that means I go down 3, and I go right 4. 1, 2, 3, 4. And so my next point will be down 3 and over 4 from where I started. If I use this one right here, that would mean that I would go up 3 and left 4. All right? And so if I did that, I would be over here. Either way, you can see this is going to fall on the same line. Once you have 2 points, you can graph a line. That's all you need. 2 points will graph the line. You do not have to do 3. I was just showing you can go either way. All right? By the same token, if it's positive, so let's say your slope had been 3/4, positive 3/4. And let's say that 3 and 4 would take you off the graph. 2 negative movements would also be a positive. So if you have a positive slope that takes you off the graph, you can do 2 negative movements. That will also be a positive slope. This is write the equation of the line through the point negative 5, 6 with a slope of negative 1/2. All right, so they gave us a point, but they did not give us the y-intercept. If they had said, here's the slope and here's the y-intercept and write the equation of the line, then you can literally just take it and you can say, well, plug the slope in here, plug the y-intercept here. Okay, but they didn't give us that. They gave us an xy, not necessarily the y-intercept. And so what you can do is you can take that x and actually fill it in here for the x. You can take the y and you can fill it in for the y. You can take the slope and you could fill it in for the slope. And then all you're missing is your y-intercept, which is what you really need to write the equation of the line. So you're just going to plug in what you have and solve for what you don't have. And so if I take this, I would say y, well, my y is 6. So 6 equals m. My slope is negative 1/2. X, my x is negative 5. And I do not know my b. So then you just solve for your b. You're going to multiply your negative 1/2 and your negative 5. And then you're just going to add that guy over or subtract depending on what you have here. In this case, add. Add your 5/2. All right. Or actually subtract. I should have said that correctly. There we go. Subtract your 5/2. All right. Change this to a common denominator. 6 over 1 is going to be 12, right? Over 2. Right? So you want to change it to a common denominator. 6 over 1 is going to be 12 over 2. So 12 halves minus 5 halves gives you 7 halves as your b. So now you know your slope, your m, and you know your b. And they want me to write the equation in slope-intercept form specifically. So now I'm going to write the equation plugging in my m and my b. So I would say y equals m x plus b. All right. And so if you know a point and the slope, you can use this. You can use your slope-intercept to find your b. Anytime they want the equation in slope-intercept, you have to have your slope and you have to have your y-intercept. And so you can back into it if you know at least one point. So here they've given me 2 points. We just talked about our slope equation yesterday. It is y2 minus y1 over x2 minus x1. So in this situation, you would have to find your slope first. Then you can pick either point to solve for your y-intercept. Either one is going to give you the same y-intercept. Okay? So go ahead and try this one. According to the U.S. Lacrosse Annual Participation Survey, the number of youth players increased from 300,000 in 2009 to 400,000 in 2013. Okay, write a linear equation modeling the growth of the sport. And so what they've actually done here is they have given us an XY. In this case, they want the years to be the X and the number of players to be the Y. So they have given us the 2 points, 2009, 400,000. And they've given us the point 2013. Sorry, this is 300,000. 2013, 400,000. All right, XY, XY. Similar to what you just did, they want us to write a linear equation modeling this growth. All right, and so even though it doesn't look like they've given us an XY, they really have. And we're going to do exactly what we did. We're going to find the slope, and then we're going to find the Y-intercept using the information that we have or using one of the points. So this would be my X1 and my Y1, X2, and my Y2. So to find my slope, I'm going to say 400,000 minus 300,000. And then I'm going to say 2013 minus 2009. I will get 100,000 over 4, which reduces to 25,000. This means 25,000 players per year join the sport. That is my slope. Sometimes they'll say it that way. They will say this much per year, and that tells you the slope without having to solve for it. And sometimes they'll do it like this with an XY, XY. All right? Then to find the actual equation, I need to do exactly what I just did on the prior example. I need to take my slope and one of my XYs and solve for my Y-intercept. They used the first one. So we would say 300,000, that's Y, equals M. That's my 25,000 that I just solved for. X, in this case, my X is 2009 plus B. All right. I will multiply these two and then subtract it over. So when you multiply these two and then subtract it over, and actually they actually just did 9, by the way. If you'll notice in theirs, they did this and that. So they just did it from 2000. So they just did 9 years and 13 years. So in the book, you're going to see just a 9 there. But you're going to get B equals 75,000. All right, 75,000. And so if I want to then write the equation, Y equals M X plus B, that would be my equation showing how the sport is growing. All right. Like we talked about yesterday, parallel lines have the same slope, perpendicular lines have negative reciprocals. And so they want us to write an equation through this point right here one that is parallel to this line and one that is perpendicular to this line. So let's look at the line they gave us. If I look at this line and I start here, I go up 2 and over 1. So this line will have a slope of 2. The equation for this line is going to be 2x plus my y-intercept is 0. So y equals 2x is this equation. If they want it parallel to this line, the only thing I actually care about is the slope. I don't care about the y-intercept at all. I only care about the slope because that's what determines parallel and perpendicular. I need to look at this point P right here. What is this point? Well, this is the point -3, -1. So they want it through the point -3, -1 and parallel to this line right here. So for parallel lines, my slope should be the same. My slope is 2. This slope should be 2. So I'm going to do what I've done. This is my x. This is my y. Y equals mx plus b. -1 equals -6 plus b. Added over, my b is 5. So this equation for the parallel line should be y equals 2x plus 5. Perpendicular. If my slope is +2, then my perpendicular line should be the negative reciprocal. So my slope here should be -1/2. I'm going to do the same thing with that point. Y equals m times x plus b. -1 equals +3/2 plus b. Subtract your 3/2. You're going to get -5/2. All right? Y equals -1/2 x minus 5/2. That is perpendicular.